Hi friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if I'm visible and if my audio is clearly audible? Can you please confirm that? Again, we'll get started in a few minutes at 7 p.m. sharp. We have a few minutes before we jump into the actual live session. So if you have questions, feel free to shoot them in the chat window. I'll try to answer as many as possible right now. We'll start the session itself at 7:01 or 7:02, and at the end of the session, as usual, we will take some general Q&A. Cool. Okay, good, all good, very good. Thanks folks, thanks for the confirmation. So no glitches whatsoever. We'll get started in a few minutes. So any questions, feel free to shoot them and I'll try to respond as best as I can. Okay, so Deepyan says, how to optimize the revision process. Like today we'll be finishing 2 subjects. So what should I do now? So Deepyan, my suggestion here is if you're finishing 2 subjects or 2 to 3 subjects, right? Once you finish 2 to 3 subjects, you can actually take maybe a 2-day break or so, if time permits, and revise everything that you have done, right? Also, we have, you can take subject tests as part of revision or multi-subject tests that we have as part of the existing test series. The new test series, we are in the final stages of putting it in place. We will launch it very soon, hopefully in a week to maybe 10 days max, hopefully. Okay, so that's what we would suggest in terms of revision itself. So Ayush says, I'm going with the live session schedule, but I'm lacking a few topics. How to cope with topics where I am lacking? Okay, good question, Ayush. So if you're lacking in any topic, try to just spend extra time, especially on a weekend or something like that. Try to just allocate little more time for these topics and try to fill in those gaps if you can. If you don't have time, just make a note if the amount of gap that you have is small. If it's just, let's say, a couple of topics here and there, that's okay. When you revise the whole subject or when you revisit the subject, when you're revising in your monthly revision or in your like every 2 to 3 month revision, you can always go back to these topics, right? So don't worry too much about having a few gaps here and there. You can always fill them in your next iteration, or better still, in the next set of revision that you would perform or that you would do yourself. Cool. So Mission says is doing the practice test questions while completing the syllabus is good enough. That's a good start, Mission. Try to finish the practice test questions. Once you finish a subject, try to take some of the subject tests. And once you finish 2 to 3 subjects, do the subject tests. That's the best order that you can follow. While you're going through a subject itself, just doing practice tests is good enough, because if you're doing the practice tests well enough, that's good enough practice. But if you have time, try and do some previous year questions also, or subject tests and things like that if you have time. But just going through the practice tests is a very good start. Do you think the competition is increasing every year? Nitish, I don't think so. Again, it changes from year to year based on the job market, based on other factors. But the competition per se is not significantly different from other years, right? So it's not that the competition has changed significantly in the last 3 to 4 years also. So Nikhil is saying, what could be a good strategy for the next 8 months? It's the same thing. You can just go to our YouTube channel where we discuss about how to plan your whole preparation. Just do that for the next 6 to 8 months. You're good to go. Okay. In DLD, I'm struggling in sequential circuits. Okay. This is Manoj. So again, we will solve some of the questions. It's actually, sequential circuits is the only tricky part in whole of digital logic design. But when we solve the questions, I'll also explain how to think about it. Again, if you have watched some of our course videos, we go very step by step when we explain sequential circuits and counters. They're actually simple concepts if you know how to tackle them. I'll try to cover some of it in today's session. Hopefully by the end of it, you lose that fear. Again, while many of us say sequential circuits are a tricky concept, they're only tricky in relation or in comparison to other topics in digital logic design, like combinatorial or combinational circuits and Boolean algebra, minimization, Karnaugh maps, etc. In comparison to them, it's slightly tricky, but overall, it's still a fairly simple topic to score. So you can easily score 90 to 100% marks in digital logic design actually. So B2 says there are some topics missing in combinational circuits. B2, we don't think so. We have created all of the course content keeping in mind last 20 years of GATE question papers. Again, we can spend a whole semester studying only digital logic design. It's a big field. If you take standard like electronics textbooks, we can spend like 100 hours or 200 hours just learning digital logic design. Our objective is to be on par with the GATE syllabus. If you think there is anything fundamental or anything major that is missing, do let us know. We will add that. But our team has gone through like last 20 years of question papers before creating it. Again, please don't compare what we have in GATE syllabus or what we cover to a standard textbook, because a standard textbook could be covered in 2 semesters, right? Like, because standard textbooks for digital logic design are also used by electronics engineers and electrical engineers, right? So don't compare it with a textbook. Please compare it with the last 20 years of GATE question papers. That's a better way to see if there is any topic missing. Okay, so cool. Abhinav, thank you very much. I'm happy that you like the math content and you're more confident now. I mean, again, math being one of my favorite subjects, I really like the fact that you enjoyed it and it's become your favorite subject. The joy of computing and the joy of math is something that we try to inculcate in our students. So thank you very much for that. Cool. So some of you are asking about scholarship test. Again, I think we mentioned this in almost every live session. We will do it as soon as the COVID wave reduces. It's still significant in some parts of India, and as soon as the semester exams for most students in most colleges is over, right? And the syllabus itself, we will announce that. Don't worry. We will give you all the content for it, publicly available, free of cost, so that you can watch all those videos and then attempt the scholarship test. So don't worry about it. Test series, I think we will have it ready in 1 to 2 weeks from now, maybe 7 to 10 days. Worst case is the 3rd week of June, but we'll try to do it as soon as possible. Somebody, Adarsh is saying GATE versus interview prep course. Which one should I choose? Please call us on the phone numbers, because then we can guide you in a very personalized fashion. I can give you a general answer here, but that may not be relevant to your context and to what you are looking for. So it's better to call us or email us so that we can give you much more personalized guidance. Where do you think IIT professors frame the GATE questions from? Very nice question, Athan. Or do you think they just sit together and make brand new ones? It's not so. So very often, like I've seen professors create some of these questions myself, and most of these questions are based on previous year questions. So they take all the previous year questions, and then based on that, because they don't want, like, professors at IITs and IISc are fairly smart. They've been studying the same subject and researching the subject for decades now, right? So what they do is they try to keep it at the same standard, or maybe slightly above or slightly below the same standard. And what I've observed, what a lot of our mentors have observed, is professors typically take a lot of these questions from standard textbooks from which they're teaching, or assignments that they give for their undergraduate students at IITs, or equivalent. So that's actually a great pool of questions. That's why in a lot of our practice tests, in a lot of our test series also, we borrow a lot of questions and modify them into the GATE format. We take questions from standard textbooks, assignment problems at top universities from MIT and Stanford to IITs, IISc, etc. We take all of them, frame it into the GATE format, right? So most of these people, that's what they would do. And from my limited understanding, professors who teach these core computer science subjects, everybody contributes questions, and there is a final committee which randomly picks or which chooses questions, whichever is the organizing committee. So questions come from literally every institute, every participating institute, and then whichever, like this year it's IIT Kharagpur. So there would be a panel there. There will be a separate sub panel only for computer science. They'll pool all these questions and pick the ones that they think would create a good paper. So Kiran is asking about live classes for Applied Gate. So the way we do our Applied Gate course is we have already all the concepts taught. Anywhere you have a problem, you shoot us a question, and typically in working hours, during the day hours, we typically respond within 3 to 4 hours. Worst case, we could take up to 24 hours to resolve your questions. The purpose of this is, in a live class, let's assume there are 100 students or 200 students in a class. An instructor cannot give personalized attention to everyone. On the other hand, in the format that we have, you can just shoot us an email or leave a comment in the comment section, and you get very personalized answer from our mentors. And you can also see questions that others have asked without spending tens of hours of time sitting in a live class. So it's a better optimization of time. We have these live sessions that we're conducting twice a week, some of them publicly on YouTube, some of them privately for our students. For example, Digital Logic Design 2, the session 2 was privately conducted for our course enrolled students. 3 is publicly available here. Again, I'm sorry, I lost the track of time. Apologies for that. Very sorry for it. So let's go into the live session itself. I'm very sorry. I just lost track of time. I just realized it's 7:07. Okay, let's get into it. So can you please confirm if my screen is visible and if I'm audible? Can you please confirm that? We'll come back to the general Q&A at the end. Okay. So can you please confirm if my screen is visible and if I'm audible? I just changed the setting right now. Can you please confirm in the chat window so that I can proceed? Yeah, cool. Thanks. So let's go into the live session itself. At the end, we'll anyway have a general Q&A. I promise you that. So this is the last live session about digital logic design. Again, if you go to the chat window, there is a pinned comment at the top, which gives you the whole schedule. Right? So if you go to the chat window, again, I can show you that. Anyway, you can see it right at the top of the chat window. There is a post by Gate Applied course, which is a Google Doc, which tells you the schedule. So as of today's schedule, it is digital logic design, the last part. And the topics that we have are sequential circuits and counters. Typically, you'll encounter 2 to 3 marks, depending on the year. And we'll solve some interesting questions from sequential circuits and counters. This topic, in relative terms, as compared to combinatorial or combinational circuits and Carnot maps and minimization, this is slightly tricky, but it's not hard. We will see that when we solve these problems, right? And let's focus on solving these problems today. We have about 5 problems. Once we are done with it, I promise you, we will spend some good time on the Q&A. But while we are going through it, let's just focus on solving the problem. That's important, please. Cool. Here comes the first question. This is an interesting question, very typical of GATE. So take your time, be careful, solve it. This is an MCQ because nothing is mentioned here, so only one option is correct. Sorry. Please post your question. Please post your solutions or answer in the chat window so that I can comment on it, and we'll anyway solve it at the end as usual. Okay, I see a few options from you folks. Again, please just verify it. This problem is, little tricky in the sense that it's very easy to make mistake. I'll solve it step by step with you anyway. But please be careful. This is a typical 2-mark question in GATE. So please be careful. Manish has a good point that he got AR 217 but he forgot everything. That happens to all of us, Manish. The moment you stop revising and we stop looking at some of these concepts, we all forget. It's only natural. Like, even though I've taught all of this, I often forget concepts and I go back and rewatch my own videos or read through our notes. So that happens to all of us. If we don't constantly revise, we will forget it. Please take your time. There is no hurry. Go slow, but it's important to get the correct answer. I see almost all 1, 2, 3, 4 as the options here. So anyway, we will solve it together. But please recheck your answer. Those of you who have already put in your answer, please recheck it once. So it says, what are the following is correct state after the 5th clock cycle? Okay. After the 5th clock cycle. Okay. Okay, I see a lot of variability in the answers. That's okay. Anyway, please take your time, solve it. Please cross-check your answer. I literally see all 1, 2, 3, 4. Now I am doubting whether my answer is correct or not. Anyway, we'll solve it together. Good to see you, Divyank. I remember some of your answers last year. Cool. Happy to see you. So the question clearly says, which of the following is a correct state after the 5th clock cycle? Anyway, let's solve it, guys. This is slightly tricky. I can imagine that. So this is by gate standard, typically medium/tricky. First and foremost, 1 XOR 1 is 1. Right? That's the first observation. So one input to your 3-bit adder is 1, 1, 1. The other input is coming from the state of your 3-bit or 3D flip-flops, right? So first, initially what's happening? At the very outset, the clock is not there. There is nothing. So what's happening here? This is 1. And you are told that the initial state is 1, 1, 1, right? So if you look at 1, 1, 1, this is your initial state, right, of the D flip-flops. And what do you have here? You have 1, 1, 1, right? So you have 1, 1, 1 plus 1, 1, 1. So this is equal to, so 1 plus 1 is 0, carry 1, 1, 1, 1 is 1, carry 1, 1, 1, 1 is 1 and carry 1. We can just ignore the carry 1, right? So you get 1, 1, 0 here. Now to the second bit or the middle bit, you have your NOT gate here, which is going to feed into this, right? So what is the output of this whole 3-bit adder now? So this thing will get negated. So this will turn into 1 0 0. So we have to be slightly careful to avoid mistakes. So now before the first clock cycle, right, because the output that you're going to get here, right, the output that you're going to get here is or the inputs to be precise, your D0, D1, D2 is going to be 100, right? So the moment the first clock ticks, after the clock ticks, what happens? After the first clock tick, you get the state of the system as 100. So after the first clock cycle, the state of the system is 100, right? Simple. Till now we have understood, right? Fairly simple. Now let's go to the second clock cycle. So now this 100 will be fed back into as input, right? This input to the 3-bit adder is fixed. This input now is going to change to 100. So as the next step, I'll just change the color here so that it's easy for us to track. So we have 111 plus 100. Again, whatever I'm writing here is after the first clock cycle, because when the moment the first clock ticks or the first clock cycle happens, these values will be 100. So then you have 111 plus 110. So what would this result in? You have to be slightly careful to avoid mistakes here. So 110011, 11 is 0 and a carry of 1. We can just ignore the carry. Now the middle bit is going to get negated, right? Because we have this. So you have 001, right? Now what happens? Let's assume there is a second clock tick. Now the moment the second clock tick happens, because this is a delay flip-flop, right? It's a D flip-flop. So whatever is the input will be the output. So as soon as the second clock ticks, what is the output here? You get an output of 001. So this is after second clock tick, right? Now let's go and check out something different. Let's go and check out, okay, let me get a slightly darker color. Okay, so then this output is again fed back. You just have to be slightly careful. So one second, let me use a different color here quickly. Okay, so you have 001 plus 111. Again, if you just go through, I'm just going through slowly so that you can follow me carefully, because some of you are confused with this. So it is Q2, Q1, Q0. Yeah, so that's the order, right? You always have the 0th bit as Q0, first bit, or if you're writing a number, it is Q2, Q1, Q0. That's a typical standard format that we apply always. Okay, so 001 plus 111. So this is going to be 1 plus 0 is 0, carry 1, 1, 1. Like this is 111 plus 1, right? So it's going to be 100, right? This anyway is going to get carried out, so we can ignore this. So the second bit here will get complemented. I'm just doing it carefully because I'm not sure if I made a mistake, because there are so many answers here. I just want to be careful. So 010, then you have your third clock tick. Whatever is the input, which is 010, will be the output after third clock tick. So 010. Till here everything is clear. So now what do we have? We have 010. Okay. So 010. This is after the third clock cycle. Now let's go to the fourth clock cycle. You have 010 plus okay, so you have 010 plus, again, same 111 which is here. There is 1 here, right? Same 111. So this will become 1. 1 is 0, carry 1. 1 is 0, carry 1. Again, the reason I do this carefully is because I've done silly mistakes with these problems in the past, right? The second bit is getting complemented. So you get 010. So 3 clock cycles are over. Now the fourth clock. With the fourth clock cycle, what happens? The input now is 010, so the output also will be 010. Done. Now let's go to the fifth clock cycle. Before the fifth clock cycle, what happens? This 010 will be fed back into the system. Sorry, 011. I'm sorry. I made a mistake. See, sorry. Only the second bit should be okay. Only the second bit should be complemented. This should stay 1 only. I'm sorry. Okay, so this is 011. So what do you do now? You take 011 plus 111. What will this be? 110. Carry 1, 111, so you get 1, and you get 1 here. 1 is 0, carry 1. We can just ignore this. Now this will get complemented, which means this will become 000. So the input before the fifth clock cycle, the input is 000. After the fifth clock cycle, what is the output now? It's going to be 000. Again, the question says after the fifth clock cycle. The fifth clock cycle has ticked, which means whatever is the input will get passed to the output, and your answer is 000. Is this clear? Is this clear, folks? Any questions? Yeah, I corrected this. Thank you. Yeah, I made that silly mistake. Thank you for that. Right. So the answer is 0, 0, 0, which is option 2, right? Yeah. Simple. Again, this might look like a tricky question, but all we had to do, the most important part here is to go through the steps carefully. We understand how a D flip-flop works. We understand how an adder works. So we just have to go step by step. Again, while it has taken slightly some time to solve this in this setup, this question is typically a 2 marks question. I have taken more time because of 2 reasons. I wanted to explain this step by step carefully. When I solved it, I think I solved it in like 3 minutes. And I make mistakes with these bit additions and bit complements. You saw me doing this mistake here, right? So I'm slightly careful because I know that I do silly mistakes like this. But this is like a typical 2 mark question. Okay. So you can easily score 2 marks if you're careful with it. No, so the carry out, so if you see this 3-bit adder, this is carry in. So there is nothing about carry out here. So we just ignore carry out. Okay, so this adder is designed because there is carry in, which is initially 0. Again, those of you, again, this question could have been trickier if carry in was 1, right? So the carry is completely, the carry out is not fed into anything back. So by default, the carry in is always 0, right? So that's it. Simple, neat question. Okay, cool. So let's go to the next question now. Okay, this is also an interesting question. With respect to synchronous circuits, you just have to be careful. You just have to look at the timing, how is the clock behaving and things like that. If you do that, you'll get answers correctly. That's why even in our course videos, we explain all the concepts through some examples. Ankur is asking what is the initial state. That doesn't matter because we are asking what sort of counter it is, right? So that doesn't matter in this context. This is typically considered an easy question by gate standard, typically like a 1 mark question. Good. I see most of you getting it right. Very good. It's an easy question. If I recall well, we explain using a very similar diagram on how to create counters in our course videos, in one of the course videos at least. Very similar circuit we use with a toggle flip-flop. Good. Very happy to see this. Most of you got it right. Very good. So I think most of you are doing well with easy questions and little falling behind on medium, which is okay, which is not a problem because you can improve over the next few months. If you solve all easy questions well, and if you solve a few medium questions also well, and if you don't make silly mistakes, you'll get a good rank. I'm not saying you'll get in the top 100, but you can easily get in the top 500. Very interesting, Ankur, very nice suggestion. I think this question could have been modified to make it slightly more interesting and tricky by saying, is it an up counter or a down counter? Very nice point, Ankur. Very good. That would have made it slightly more interesting, but we also want to have a few easy questions, few medium questions in these live sessions. That's a good point. I think there is one such question in the practice tests or in the subject test, if I recall well. Cool. Okay, let's solve this. Straightforward, right? So this basically says that this is a negative edge triggered system, right? So this is like a negative edge triggered, this is negative edge triggered, right? We describe what is negative edge triggered in the course videos. And if you see this is a standard ripple counter, right? This is how ripple counters or asynchronous counters are designed, because this clock symbol is only going here, right? And this would get triggered when the clock goes down, because this is negative triggered, right? So which, yeah, this is a negative triggered, negative edge triggered, right? So this will be once you're, sorry, this is negative edge triggered. This is a negative edge triggered. So when we are going from when we are going from 1 to 0, right? When you're going down from 1 to 0, this will trigger, right? So this is a standard negative edge triggered clock. Okay, so what happens is when this clock symbol is applied here, when this flip-flop changes its state, this flip-flop need not, because this flip-flop's clock depends on this flip-flop's output. Only when Q1 goes from 1 to 0, when it goes from state 1 to state 0, because all these are negative edge triggered, right? Only when this flip-flop is going from state 1 to state 0 will this get triggered. This whole circuit will get triggered only when Q2 is going from 1 to 0, which means all three flip-flops are not synchronously changing. In a synchronous circuit, what do you have? You have the same clock signal being fed into all the three flip-flops. That's not happening. Output of one is fed into the clock of the other, right? So this is a standard example of a ripple counter or an asynchronous counter. Look at all the options. You can get rid of this, you can get rid of this. Now the question is it a mod 7 counter or a mod 8 counter? That's what we have to determine now. That's all matters now, right? So let's see, again, if you want to check whether it's mod 7 or mod 8, very simple. Start with 6. Imagine if the state of the system, right? This is your Q3, Q2, Q1, right? So your whole bit vector is Q3, Q2, Q1. So if this value is 110, what is the next state, right? From 6, if you go to 0, that's a mod 7 counter. From 6, if you go to 7, and then after 7, if you go to 0 again, it's a mod 8 counter. It's you don't have to check everything. You can just start with 6 and check only these three things. Okay, so Q3, Q2, Q1, I will just write it as Q1, Q2, Q3, because these flip-flops are ordered like that. I want to avoid silly mistakes. So this is a 0, 1, 1, right? So now let's see what happens. So, okay, so the current state is 0. So let me just write it here. The current state is 1, the current state is 1. So let's assume the current state of the whole system is 6, which is 110, or in this case, because this is the lowest significant bit, it is 0, 1, 1. Cool. Now, if you give a clock, like if you give a negative edge trigger to this, what happens? So this is a toggle. See, this is a toggle flip-flop, right? So everything is set to 1. This is also set to 1. This is also set to 1. Cool. So this will flip. So this will go from 0 to 1. Now, when it is going from 0 to 1, look at this. When you go from 0 to 1, what happens to this clock? This clock is at 0. It went to 1 now. This is a positive edge trigger. So this is like a positive edge triggered clock. Right? This signal is like a positive edge trigger, but this whole flip-flop will only get activated if you have a negative edge trigger. So this flip-flop will not get activated now. So this will change to 1. So Q1 will change to 1. Q2, nothing will happen, right? Because remember, look at this circuit. What you're getting as an input feed, what you're getting here as an input is a positive clock trigger, right? What you need is a negative edge trigger. Right? What you're getting is a positive edge trigger. So this will not change. If this does not change, this won't also change because this is staying at 1 itself. So you're getting 1, 1, 1. So after 6, what you're getting is 7. Right? If you're getting 7, it can't be a mod 7 counter. Simple. It has to be a mod 8 counter. Again, let's just check that just to be sure. Again, those of you who are confused, you don't have to check it because that's the only option left. But let me just help you with it so that you understand how to analyze these circuits better, right? So the current state is 1, 1, 1. Negative edge triggered, negative edge triggered, negative edge triggered, right? So let's assume there is a negative edge trigger again. What happens now? This 1 will become 0. So what happens to the circuit here? This was at 1 till now. It went to 0 now. So this is like a negative edge trigger now. From 1, it went to 0. If there is a negative edge trigger, this circuit will get activated. So its state was 1 because it's a toggle flip-flop. This will become 0. And now look at what's happening to this clock signal. It was initially 1, right? It was initially 1. Now it's gone to 0, which means there is a negative edge trigger, which means this will also get triggered. And because the toggle T3 is 1, this will also become 0. So you're getting 0, 0, 0. This is behaving exactly like a mod 8 counter. Again, whenever you're doing analysis on things like that, these are very easy problems. If you know how to, again, those of you, I've taken slightly more time on this problem and explained it carefully, especially for those people who think synchronous circuits are a little tricky or hard. They are not. You just have to go through the logic step by step and understand it. Most students got it right, which I'm very happy with. Cool. Let's go to the third question now. Okay. This is an MSQ. This is an MSQ, so please think about it. If there is any term that you may not know about, just try to think about that term from common sense perspective. If you don't know a term, if there is some term in this whole question that you don't know, think of what it might mean logically. This is an MSQ, so multiple options can be correct. I see some of you putting your answers. Good, good, good. This is actually an easy question. It is slightly on the medium side because it's an MSQ. Otherwise, this is an easy question. I'm very happy to see most of you got it right. So good, good, good. Very good. Okay, so let's wait for a few seconds and then we'll solve it. Okay, so let's tackle this question. So let's look at all the 4 options. It says which of them are correct. Okay, good. So the minimum number of flip-flops required to count this number base 10 using a binary ripple counter is 15. So for any binary ripple counter that you have, so if you have n bits, right, using n bits, as we have also seen in our course videos and also with the previous example, you can create a you can create a mod 2 power n, right? You can easily create a mod 2 power n binary counter, right? Very easily. Now if n is 15, what is 2 power n? right? So then your 2 power n, if you just use a calculator, you'll know that this is 32768, right? So in mod 2 power n, right? So you can count from 0 to 2 power n minus 1. What is 2 power n minus 1? It is 32767. That's what you want to count, right? The minimum number of flip-flops required to count this is 15. That's what it's saying. So if you have 15 bits, right, you need at least 15 bits to create a mod 2 power n counter, right? Which means if you have 15 bits, or 15 is the minimum number of flip-flops that you need, or the bits that you need, mathematically speaking, to create a counter which will count from 0 up to 32767. So this option is correct. Very simple. Now the second one says a ring counter. Those of you who may not know what is a ring counter has this ring-like structure. Suppose imagine I have some flip-flops here. It has this sort of structure. That's what a ring counter is. So it says a ring counter could be designed using a shift register. What is a shift register? Shift register is simply your, let's assume you have a D flip-flop here, right? Suppose this is a D flip-flop, right? So a shift register basically means whatever is the input in this bit will be shifted to the next bit, right? So again, you can see this, that if you have a circuit like this, let's assume this is your clock signal, right? Let's assume this is your clock signal and this is your cues, right? With a little bit of hack here and there, using a shift register, because you're shifting the bit from one bit to the next bit, and using this loop-like, ring-like structure, right? You can create a ring counter using a shift register where you're shifting data from one bit or from one flip-flop to its next flip-flop. Again, if you want to see the exact diagram also will look very similar to this. I just, let me just show you that. So, I mean, if you want the ring counter Wikipedia, so yeah, so this is how it will look like, right? You have D flip-flops, and again, you can just ignore the reset button. Again, simple structure here, right? You have your clock signal triggers and things like that. Very similar structure to this, which I've drawn. So so the second is also a correct option for those of you who did not know what is a ring counter or a shift register. The third one, a flip-flop is said to be transparent if Q output is complementary of input. No. So if Q output is same as your input, if your output Q is same as your input, then it is said to be transparent, right? Like your D flip-flop. Your D flip-flop is basically a delay flip-flop. Whatever you input, you get it as output, right? So if you think about it logically, that the D flip-flop is said to be transparent, not the toggle flip-flop. Toggle flip-flop does the complement. We don't care about it now, right? So it's transparent because whatever you're sending as the input, you're getting it as an output, because then this whole system looks like a transparent glass box where whatever is going in is coming out. Okay. So B is, sorry, 1 and 2 are correct, 3 is not, because it's said to be opaque, or it's said to be non-transparent. Let's not use the word opaque. It's said to be not, for a flip-flop to be transparent, the Q has to be same as input. Okay. The 6-bit counter has a maximum modulus of 64. Yes, because 2 power 6 is 64. Using a 6-bit counter, you can create, using 6 flip-flops, you can create a counter with mod 2 power 6, which is 64. Simple. So 4 is right. Most of you got it right. Fairly simple problem. It's an easy problem. It could be considered medium in gate, primarily because this is an MSQ. Okay, here is an interesting question. So for the previous question, Ankur, when you have a shift register, most shift registers are by default implemented using D flip-flops. I mean, that's a default one. Of course, you can also implement these with more circuitry and other flip-flops also, but typically it is implemented using D flip-flops. So that is inherent in the second option in the previous question. This is an interesting question. Take your time, please be careful. because anyway, please be careful. That's all I'm suggesting you here. We'll come to it why in the solution part of it. DK says he's very bad at these types of questions. DK, don't worry. Just think of how a SR flip-flop should work, how a JK flip-flop should work. Plug in the values and see how the data or how the whole bits flow. That's it. Just see for each clock cycle how things behave. Again, these questions are easy. If you're a little careful, you can do wonders here. Again, I'll solve it for you because I want everybody to lose that fear of sequential circuits, because it's actually not that frightening. It's an MCQ, folks. It's an MCQ. Oh, are there multiple options that are correct here? I didn't realize that. It's an MCQ. Unless stated, it's an MCQ. I think this cannot be an MSQ, given the options. Somebody is asking, what is the initial state? Why do you care about the initial state? All that we are saying, pick an initial state of your choice. All that we are saying here is this circuit, what sort of flip-flop is it equivalent to, and where should each of the J and K or S and R should go to. That's all we are asking. This is an MCQ. Pick the most appropriate answer. Again, it's very scoring. If you're a little careful, you can score marks. Again, by gate standards, this is often considered as a medium level problem, but it's actually easy to solve. If you're careful, you can easily get marks here. This is a very common pattern that we observe in gate, especially with respect to sequential circuits. This question is also very prone to silly mistakes, so please be careful. There are many ways of solving it. Good. I see most of you getting the right question, which is very good. Which is very good, as always. Like if you're solving this sort of questions, right, you're fairly comfortable with sequential circuits. I'm still surprised how some of you who are doing so well in all these questions have messed up the first question. I think in the first question, most of you were not warmed up or you made silly mistakes. First question, I expected a lot of you to get good answers. Anyway. Most of you got it right, some of you got it slightly incorrect, but again, slightly incorrect means you lose marks in MCQ. Okay, so let's tackle this question now. Okay, so you're given some circuit, you're told that C equals to Q, right, for the final circuit. And if you look at it, you either have SR flip-flop, JK flip-flop with A, B to be some other inputs, right? So let's actually see what happens. If this is A and B, this is your Q, right? So this is your Q dash. Now what is the output here? What will be the output here? The output here is Q. Okay, let me write it carefully here. Okay, let me just write it here so that it's clearer. So you have Q into A dash, right? It's a logical AND followed by NOT. So NOT. Now what about this circuit? This circuit is B and Q dash NOT, right? So this the output from both of them is going into this NAND gate, right? So NOT and NOT, right? So this is what is going in as D now. So this is your D. Okay, so this is your D. Let's simplify the LHS first. So just apply your De Morgan's law. So A dot B complement, right? Or X dot Y complement. So you get Q dot A dash complement becomes normal plus B dot Q dash complement gets cancelled out. So this is your D, and whatever is your D, as soon as the clock ticks, Q will become D, right? So this is equal to your Q next, right? This is your Q next, right? If you think about it logically. So this is the expression that you have. I will just write it slightly differently, okay? Just for our ease. So what we had was, okay, same thing. I'm just rewriting this expression here. What we had is, we had A dash Q plus B Q dash equals to Q next. Now we have to figure out, given this simplified expression, now let's figure out whether it's JK, SR, etc. Again, JK, SR are very similar except when you have J and K or S and R equals to 1. So let's just say it could be J, it could be K, we don't know, right? Again, J is same as S in an SR circuit, K is same as your reset, standard stuff, right? And now we don't know what A and B can be, right? So let's assume you have, let's write the expression for Q next using this. Now you can try both options and let's go figure it out. Again, you can plug in all these values and think about it. Let's assume I plug in this. I'll show you how to plug in one value. You can plug in the same way for others also. Suppose if I say A equals to K, suppose if I say A equals to K and B equals to J, let's just say I say this. If this is 0, 0, what happens next? Okay, so what am I saying? A is 0, B is, you have to be careful to avoid mistakes, right? B is J, okay, B is also 0. So if this is 0, this is 0, what happens? This becomes 1 and this becomes 1, right? So 0, 0, this stays as Q. Q next equals to the older Q, right? Q next is same as the older Q because this is, this became 1 into Q plus 0 into Q dash. So it is Q. Now if this is 1, 0, we'll see all four possibilities, right? So if it is 1, 0, then what happens? Okay, let me just erase this. Again, you have to be careful because J and K are in this different order as A and B. So A is 0, B is 1. Now what happens? If this is 0, so 0 complement is 1, 1 into Q is Q, 1 into Q is Q, yes. So this is 1 into Q complement. So Q plus Q complement. Q plus Q complement is 0. Sorry, Q plus Q complement is 1. I'm sorry, right? It's 1. So you are getting 1. So this is behaving like a set or a J input. Look at this. In a set, in a SR flip-flop, what happens? If S equals to 1, the value will be set, right? If S and R or J and K, both of them are 0, it will stay this. Let's look at the other possibility, 0, 1. Okay, so again, we just have to plug in and think carefully, that's it. So A is 1, B is 0. So then this becomes 0 into Q, so becomes 0. This is B, one second, B is 0, okay, and A is 1. So A complement is 0, 0 into Q is 0, plus this is anyway 0, so this becomes 0. So this is behaving like a reset, right? In an SR flip-flop or a JK flip-flop, if you have 0, 1, it behaves like a reset. Good. Now, to decide between SR flip-flop and JK flip-flop, the most important thing is double 1, right? If S and K are 1 and 1, sorry, S and R are 1 and 1, or J and K are 1 and 1, right? So then what happens? Let's see what happens then. So if this is 1, 1 complement is 0. So this whole thing becomes 0. If B is 1, this becomes Q dash. So if both are 1, you're getting Q dash. Basically, if both inputs are 1 and if you're getting a complement, right, what does that mean? It means it's a JK flip-flop. So the right answer here is, this is exactly the table that you would expect for Q next in terms of Q for a JK flip-flop. So this is, the question says, what does this behave like? We know that it behaves like a JK flip-flop, right? Because you have 1, 1 as valid input. You just have to be careful that you have A equals to K and B equals to J, because the other option here is that A and J are just swapped. So A becomes J, B becomes K. Then you can just plug in these values and you can see it will not work. You just have to be slightly careful here. Again, arriving at this expression is simple Boolean algebra. Once you do that, you just see what's happening when you say J equals to B and K equals to A, or vice versa, right? So you'll see that the right answer is 2, which most of you got. Okay, simple, straightforward question. If you're careful, you'll get it. Last NAND gate can be, yeah, so I get it. Yeah, so you can also simplify this whole expression, but I was just going through the step-by-step process to get into this. You're right, Ankur, that we can simplify this 3 NAND gate and just write it much more better. But anyway, we just applied De Morgan's and got that. Now, some of you may argue that SR flip-flop is also a correct answer, right? I mean, some of you might argue that. Now, this is the interesting part. In an SR flip-flop, if you have 1, 1, this is not defined, right? In a typical SR flip-flop, right? Because a JK flip-flop is basically a refined SR flip-flop. That's what it is internally, right? So some of you might argue that it is also an SR flip-flop, but since this is an MCQ, a more appropriate answer is it is actually behaving like a JK flip-flop with a certain output for the given input. So if the inputs J and K are 1 and 1, it is complementing it, which is what we expect, right? Again, you can also derive this same thing in multiple ways, as Harsha is suggesting. We can take the characteristic equation and solve it and things like that. We can also do that. I'm not denying that. This will exactly look like the characteristic equation of a JK flip-flop. But in case you don't remember that, how do you solve it from first principles? That's what I'm suggesting here. Okay, cool. Good, good, good. So last question. This is an MSQ. Roshan, for the 4th option above, just plug in the values, it will not fit in. Just check that. Again, this is an easy MSQ. This could be like a 1-mark MSQ. Most of you got it right. This is a fairly simple question. We always try to end with a simpler question in general. Cool. Most of you got it right. It's 1, 2, 3. Very simple, right? Again, it's very simple. Again, I think we also explained it in the course videos. So if you have your JK flip-flop like this, how do you convert into D flip-flop, right? So you have your D input here. You pass this, you have this NOT gate and plug it in here, right? From JK, you can get D. Same thing from SR also you can get D flip-flop by just doing this. Now because you're negating this, you're guaranteed that you'll never get 1, 1 as the input. So this will also behave like your standard. So JK flip-flop, SR flip-flop is straightforward. T flip-flop is slightly more tricky, right? So the way you get, you have your T flip-flop, you have your Q dash here. So this requires an XOR gate, right? So typically you have an XOR gate like this. The Q feedback comes in and this is your D. I believe this was explained also in our course videos, if I'm not wrong, or one of the solved problems, right? So yeah, so again, you can also realize D flip-flop using a T flip-flop using XOR gate. The only additional gate that you need is the XOR. That's it. So all 3 of them are valid answers. Fairly straightforward, simple question. If you have studied this, and if you know how to construct it, it's straightforward. Right? Cool. Sounds good, folks. So let's change tracks and go into the live session with questions. Okay, we finished it fairly well. We finished it in what, 50 minutes? We started it at 7:07. 50 minutes we finished it, which is good. Okay, somebody said there is a problem. SR flip-flop with NOR. I never said NOR, no. SR flip-flop with a NOT gate. This is a NOT gate. With a NOT gate, it's valid. So Ayush says these questions are not unique like a test series. Yes, they are not. Right. So we always mentioned that the unique questions are mostly meant for a test series. For these live sessions, we don't have unique questions. We try to create some good questions. Some of them may be unique, but we never guarantee that for these live sessions. It's almost impossible. Like creating unique questions takes hours. So yeah, we never promised that, and we don't intend to have unique questions for these also. It's much harder. I think maybe some of these questions may be unique, but I'll have to cross check with my team. Good question. So Harsha says important data structures for placements. Harsha, it all depends on which companies you're interviewing for. If as part of your campus placements, if you're getting Amazons and Googles of the world, then you certainly have to be comfortable with graphs, binary trees. Those are the types of, again, some linked lists also you'll encounter. Hash tables certainly. Yeah, those are the ones that you will encounter. Queue, stacks, standard stuff anyway. What else? Those are the only major data structures at undergraduate level computer science, right? Of course, the same questions may be asked even for services companies or product-based startups, but the hardness of questions will be lower, right? So most services companies, you may not encounter graph theoretic questions. Even in graph theoretic questions at top product-based companies, it's mostly around DFS, BFS, back edges, all this, I mean, standard stuff that you study in data structures algorithms, right? Cool. So Ankur says, I'm from a smaller college and I'm a second year student and I'm preparing for GATE CSC 2022 and 2023. Okay, so you're just finishing your second year now. Got it. I have to do a lot of subjects like OS, DS, etc. That's perfectly all right. See, some of these subjects may not be already covered for you. Like I went through that same journey in my own BTech third year, where a lot of subjects because we had a very old syllabus as part of Andhra University. And that syllabus, we had subjects like operating systems, computer networks in third year and even in final year, right? So it took me considerable amount of time because I never studied in regular coursework. That's okay. Whatever subjects you have in regular coursework, try to finish them. You have a summer vacation, or probably you're already in a summer vacation, or if you're having a summer vacation now, try to do as many subjects as you can during the summer vacation because you can spend more time. Cool. So Amin says, are your data structures enough for placements in product-based companies? So Amin, if you're talking about product-based companies like Amazons and Googles of the world, what we have in our gate is mostly geared towards gate. The fundamental concepts don't change because we have taught from CLRS, right? The Introduction to Algorithms by Carmen Leeserson, which is like the standard textbook at every top university of the world. So the concepts don't change, the problems change, right? So that's why we created this whole placement prep course where we have 200 solved problems, where we actually, like I and one of my co-founders, Satish, we sit down and solve these 200 problems step by step, and we have another 300 problems for practice. So the concept of what a binary tree is or what a binary search tree is, what a linked list is, doesn't change much. It is the hardness of problems which changes, right? So while the concepts are sufficient, the problems that you have in GATE are not sufficient for top product-based companies. That's why we created the whole placement prep course. Ali says, I have missed the live sessions. How can I get the recorded sessions? Again, all the live sessions that we have done publicly are available on our YouTube. So please check them. If you're a course enrolled student, all of the private live sessions and public live sessions are added to the course structure itself. So you can go check it there. If there's any problem, do reach out to us. Do we need competitive coding if we crack GATE and study at IIT? Yes, Bitu. Yes, you do need that. So whether you come from an IIT or a smaller engineering college or you come from Stanford, doesn't matter. Companies like Google, Amazon, all the top product-based companies, they're looking for good coders who can write good code, clean code, working code, and optimized code using good data structures and algorithms. So whichever university you come from, the concepts or the skills that you learn in competitive programming are helpful. There is a fundamental difference between competitive coding and interviews. That's something that I should mention. So in competitive coding, there is no follow-up, right? Suppose there is a question, you write an algorithm and you submit it, it is tested against test cases and you're given some score. In an interview, that's not how it works. In a typical interview at a top product-based company, you're given a code editor, you write your code, and the interviewer will keep asking you follow-up questions on, hey, why did you choose this data structure? What if we choose a different data structure? Can we optimize on space? What if the data doesn't fit into RAM, right? Similarly, there are all of these very interesting engineering questions that are often asked as follow-ups. And in most interviews, even at top companies, they're not always looking for the most optimized solution. They're looking for good implementation, bug-free implementation, the quality of code, the comments you write, how you create the functions carefully. All of that is also seen in actual interviews, which is actually not part of competitive programming sometimes. Okay, so I hope this helps. How important is coding for PhDs at IITs and IISc? Fundamentally speaking, having coding proficiency is a must if you want to have a career in computer science related fields, whether you're a PhD student or otherwise. So we are also collaborating with Indian Institute of Science. We have also already, I think I mentioned this. We are doing because it's summer vacation for them from the next week. We are collaborating with them on doing a programming boot camp to primarily improve the programming proficiency, right? Because as part of the coursework at top universities like IISc and IITs, students learn a lot of beautiful mathematics, algorithms, etc. They also have some good courses where they code a lot, but we thought we can project or we can showcase them how actually industry level code is written and how you can optimize code and how you can think from a more top product based company engineer mindset. So we have conducted one bootcamp with Indian Institute of Science in Jan-Feb. We are doing one more sometime later this month. So these coding the purpose of the coding, again, IISc is where I studied. We work very closely with Indian Institute of Science, the computer science department. We're also working with other departments now, the whole EECS. So it's our way of collaborating back with the institute that gave us so much. Having said that, the coding proficiency is a must, even if you're a PhD student, because even as a PhD student, you have to write code, you have to test your algorithms. Oftentimes, you have to open source the algorithms, or even in machine learning. I can talk about machine learning because I see a lot of good PhDs in machine learning who write beautiful code because they open source that code, right? So it's a very useful skill. Yes, Rohit is asking about do we have a scholarship test? Yes. So we were just waiting for all the universities to finish their semester end exams, or at least most of them, because we can't wait for everyone to finish. But as soon as that is over and some of the COVID cases reduce, because some of the students are also sick, we know that from our own course enrolled students. As soon as that happens, we will have a scholarship test. And just like last year, the top 200 students will get scholarships. The format will be very similar to last year. Can I start the test series after completing the course? This is from Abhinav. No, my suggestion, Abhinav, for you is this. As part of the course structure itself, can you finish the, as part of the course structure, finish the practice tests. You can do the 2021 test series as part of doing the course itself. You can keep the 2022 test series for November revision. That's perfectly okay, right? So that way you'll solve like 50% of the questions during your first iteration. During your second and third iterations, you're solving 50% more, or probably about 40% of questions in the second iteration. That's what we would recommend. So Yash is saying, will the bootcamp be open for all? Unfortunately, no, because the prerequisite for the bootcamp is that you already know data structures algorithms inside out, right? So the bootcamp's purpose is not to teach you data structures algorithms. It is assuming that you already know data structures algorithms. You've already gone through graduate school. You already have like in-depth mathematical knowledge of these algorithms. It is to give you the engineering industry perspective. So I don't think it is apt for the general audience here. Okay, so Dave says, I have completed my syllabus. So what should be my revision strategy? Very simple, Dave. Simple. Solve as many questions as you can, because you're very early. Probably you're repeating your gate preparation. If you finished all the subjects now, I mean, that's phenomenal. Like, you have 8 months. You can do like what? You can solve 10,000 questions now. You have ample time. Like, you're an outlier. You're not the normal guy, which is good for you, because now solve the last 20 years of previous year questions in gate. Solve all of our test series. Most importantly, since you have time, don't run behind the volume of questions. Do these questions rigorously. Okay, solve the questions, take time, struggle through them because you have time on your side, and build that problem solving skill. That's what matters at the end, not how quickly you finished your syllabus. Okay. So Jay says, is solving lead code questions sufficient for cracking product-based companies? Yes. If you can solve for top product-based companies, if you can solve medium and hard questions, you're in good company. So Harsha says, are disjoint sets and amortized analysis, is it there for gate? No. So we have never seen questions related to amortized analysis. I mean, you can say there is amortized analysis with quicksort and things like that, but it's fairly simplistic. There is no advanced amortized analysis of Fibonacci heaps or disjoint sets and things like that. That's not part of gate syllabus, so don't worry about it. Ayush says, can you please include gate topics for your blogathon? Ayush, that blogathon is specifically meant for machine learning and data science. We will surely take your suggestion and we'll think of, again, the only reason why we are not doing a blogathon for gate is it doesn't matter, right? In the case of AI machine learning course, students, this is a way to encourage students through cash prizes and incentives so that they write blogs, because that will help them in their career transition. In the case of gate, if you write a technical blog, you're not going to get a gate rank, right? It's only through solving problems. That's why we do problem solving sessions here so much, right? So we thought it is not apt for gate. Unfortunately, we will not be able to extend it to gate. So Ayush says, which month should we finish the gate syllabus? There is no one right time. If you see the interviews of toppers last year, you'll see people who have even finished, people who are in the top 100 ranks, some of them even who are in the top 10 ranks, who finished their first iteration of syllabus only in late December and early Jan. So there is no one right time. Okay. What matters is not how fast you finish, as I just mentioned earlier, it is how well you have gone through this problem solving and concepts part. That's what, even if you have not revised it even once, if you just revised in the last 15 days, if you have gone through the first iteration with weekly, monthly and quarterly revisions, you're in a very great shape. Okay, so Bitu is asking how to practice problems from textbooks. I think I mentioned this in the previous sessions also. Most of the good questions, we've already formulated them in the gate format as part of our test series and practice problems and things like that. If you have solved all of it and if you have time, go solve the first few problems in the exercises. The problem that you might encounter is you might not have solutions for all the exercise problems. That could hurt you sometimes because you can't verify whether you got it right or wrong. That's the unfortunate part there, right? Some books and authors publish solutions, so you can check it. But my suggestion first and foremost is a lot of the good questions from there, we've already incorporated them into our practice tests, subject tests, the whole test series. So I would recommend you finish the test series that we have rigorously. We have about 5,000 plus questions in the whole system. Finish them. Then if you have time, go to the textbooks. So from which year to start PYQs? I mean, start from most recent year and go back as much as you can. I think if you go back even to 2000, that's a very good number. Like 2000 is I mean, you have done like 20 years of question papers. Some years have multiple question papers. Even if you go till 2010, you're doing a good job. But go backwards, do the 2021 2 sets, then the 2020, because there's a higher likelihood that the paper now will be similar to what we have seen in the last 3-4 years. I mean, it's a guesstimate, obviously, nobody knows that for sure. but it's better to go backwards. Go up to 2010 or go up to even 2015. That's okay. Don't worry about it. If you have time, go up to 2000. So, interesting question. How is the coursework at IIT Bombay or IISc or any of these institutes? I don't know about IIT Bombay. Well, I've interviewed folks from IIT Bombay a lot when I was at Amazon. But typically the coursework is fairly rigorous, mathematically, algorithmically, coding wise, everything is fairly rigorous. And every midterm and semester end exam is at gate level or harder than gate level. So to put it simply for you, right? So gate will feel like an easy exam once you get into these institutes. So the coursework, you have a lot of choice there. There are very good professors who are very knowledgeable, and I mean, the world is your stage then. It's how hard you can work. It's how well and how systematically you can work. Of course, there will be some mandatory courses like data structures, algorithms, or some linear algebra. There will be some mandatory courses, but there will be a lot of optional courses. You can pick any area and you can go through it. But in general, the hardness of courses is some courses are at gate level, but most courses are above gate level in terms of hardness. Cool, sounds good. So, okay, so this is interesting. Darshit says, I'm doing a job from 9 a.m. to 7 p.m. Can you please suggest a time period during which I can study for GATE? Again, very simple, Darshit. So 9 to 7, my suggestion is, since you're anyway a little exhausted by 7 p.m., have an early dinner, spend some time with family and friends, go to sleep early. Probably try to go to sleep by, let's say, 9, if you can. 9, maybe 9:30. Spend a couple of hours of quality time with your family, maybe with friends, and 9:30 doze off, wake up at 4:30, right? So 9:30 to 4:30 is what? It's about 7 hours of good sleep. So 4:30 you're fresh, study from, let's say, 5 to 8 or 5 to 7:30, right? So, I mean, this is what I would do because I'm like a slightly early guy, because once I'm exhausted, like after this live session, I can't do a lot of intellectually hard things. So whenever I have to do something intellectually heavy, like plan for the next courses or plan for this course or make important decisions, I try to do it early in the morning because I'm much fresher then. And even if I have to record videos, all of that, I try to do it earlier in the morning because there is less distraction, there is good rest. So try to squeeze in 3 hours. You can easily do that in the course of a typical work day. Cool. So Nitin says, I'm an ECE student. How can I join from start and give GATE exam for MTech CS? So Nitin, there are a lot of non-CS folks who do attempt the GATE CS because they want to pursue an MTech in computer science. That's perfectly valid. And a lot of our courses or a lot of our subjects are taught keeping that in mind, that the student may not be from a CS background. So everything is taught from scratch, assuming nothing. Like I will not even assume that you know electronics to start with. So we'll start everything from scratch and just go through some of our free videos. You'll be able to understand that. And we do have course participants from non-CS backgrounds who cracked good ranks even in the last year. So that's perfectly doable. If you just put in the effort. Of course, you might have to put in efforts at different places than standard CS folks. For example, since you come from electronics and communications, you might be fairly better than most CS people in engineering math. You most likely are better than most folks in computer organization, which you might also have learned as microprocessors. You might be better at them in digital logic design. So there will be some of these subjects which will be easier for you, but there might be other subjects which might be completely new, but we cover everything from scratch. So you can follow that. Okay, so, okay, that's all I think. Sounds good. So the test series, we are hoping we'll launch it by 2nd or 3rd week. I mean, 15th to 20th. Again, we'll try to do it as soon as possible. We just want to make sure that before we launch, everything is in place or almost in place. So 2nd week to 3rd week of June, we will push that out. Okay, sometime around middle to 3rd week. Okay. Okay, folks, thank you very much for attending this session. All the very best. Most importantly, please stay safe. Let's not get too comfortable and step out without precautions or step out unnecessarily because the COVID wave is dropping. There are still major cities of India which are suffering. So let's be cautious. Okay. Thank you very much, folks. Bye-bye.